Hey everyone, today we're diving into a game changer for your Nest.js APIs. What if I told you that with Nest.js and tRPC, you could build type-safe APIs without ever writing a single line of REST or GraphQL schema? Say goodbye to the days of writing request and response DTOs and duplicating them between your server and client. Instead, by using tRPC and Nest.js, our TypeScript types are going to be shared directly between the front end and back end, meaning we have less bugs, less duplication, and more confidence in our code. By adding Nest.js into the mix, we're getting a scalable module, battle-tested application that's going to totally transform the way you build APIs. You can see here we're looking at tRPC panel, which is auto-generated documentation for all the tRPC routes we're going to build in this application. So we're going to implement full CRUD functionality and be able to actually execute all these operations on our server with this auto-generated documentation page, another amazing benefit of tRPC. We're going to be utilizing the open source Nest.js tRPC library, which is going to integrate tRPC into our application with very little code. Let's go ahead and get started with learning how to use tRPC and Nest.js to start changing the way you build your applications. Now, in addition to creating a Nest.js tRPC backend, now before jumping in, I want to let you know, for those of you that are building full stack applications, I've got something extra. In the full version of this lecture, exclusively available for members on my site, I go even deeper into how to integrate a Next.js UI with our tRPC-powered Nest.js backend. It's the ultimate end-to-end guide for modern full-stack web development. Finally, this is all running inside of a Turbo repo so that our applications can share the same common types from our tRPC backend. So if you're serious about leveling up your development workflow, head over to my site and become a member today. I'll leave a link to that below. Now let's dive into how Nest.js and tRPC are changing everything about APIs. Alright, so let's go ahead and get started with initializing our project where we're going to integrate tRPC. So let's get started by using the Nest CLI to actually initialize our project. If you don't have the Nest CLI already available, simply run npm install-g for global at nestjs/cli at latest to get the latest version. With the Nest.js CLI available, we can go ahead and run nest new, and you can call your project whatever you'd like. I'll go ahead and call it Nest.js tRPC. I'll also go ahead and choose npm as my package manager, but you can use whichever one you'd prefer. With our dependencies all installed and our project initialized, let's now cd into our project directory, and we can go ahead and open it up inside of a code editor. So I've gone ahead and opened up the project in VS Code, and this is just the default starting Nest.js application. We have our package JSON with our scripts to actually start up our server and build our application with the Nest CLI. We have our starting dependencies, which include all of our Nest.js framework dependencies. Inside of our source directory, we have our default starting Nest.js application, where we create the application through the Nest factory and pass our root app module. We then bootstrap our HTTP server by calling listen on our application and passing in our port, which is going to be 3000 by default. So if we check out our app module, right now we have a single app controller defined and a single app service as a provider. Our app controller, decorated with app controller decorator, is exposing one HTTP route, a GET route called getHello, that is using our injected app service and returning the getHello function. So from this HTTP controller, we're going to go ahead and return the app service getHello, which in here we can see we're just returning a string. Now we marked this service as injectable, which means we can actually use Nest.js dependency injection, inject it into the app controller, and use it inside of the controller. So let's go ahead and start up our Nest.js server and make sure everything's working properly. We should be able to run npm start dev to start the dev server, which is going to compile our code, start it up, and listen for traffic on our HTTP port. So with our HTTP server started, we should be able to navigate to localhost 3000, which is where our HTTP server is listening by default, and we can see our hello world JSON response returned back to us. So our server is running properly, And this development server will automatically recompile as we make changes throughout the lecture. So now we have the starting Nest.js server running. Let's go ahead and get started with actually integrating tRPC. So the first thing I want to do is actually install some dependencies that we're going to need to run our tRPC server. Now in this lecture, we're going to be making use of Nest.js tRPC, which is a library that automatically will integrate tRPC server into our Nest.js application with minimal code and low boilerplate. It's an awesome library that is relatively new, so it's still evolving. However, we're going to use it to actually bootstrap our tRPC server really quickly. Now, I'll leave a link below to Nest.js tRPC documentation. I highly recommend taking a quick look through it. It's really small and quick to read through. We're going to be going through all of these chapters in this lecture so you have a great understanding of the library. So let's go ahead and install these dependencies. We'll go ahead and run npm install and firstly install at trpc/server, which is the actual library that's going to run our tRPC server. We also want Zod. So Zod is used heavily for schema validation in tRPC. And this is the library that will actually enforce that our schema on the client and server is actually valid. So this is one of the big benefits we know of tRPC is this strict schema validation through TypeScript natively on the client and server, and Zod is used heavily for this. Next up, we'll go ahead and install Nest.js tRPC itself, which we know is going to help us implement tRPC. So go ahead and install these dependencies and save them to your project. So with our dependencies installed, let's go ahead and restart our development server. Now back in VS Code, let's go ahead and start integrating it. Firstly, I'm going to go ahead and just get rid of our starting files that we don't use anymore. So we can remove our app service and app controller files just to clean up our project a little. Let's go ahead and remove them. And then back in the app module, we'll also remove the references to them. So we're starting off with a blank slate here. So we're going to go ahead and start off now by creating a new folder in our source directory called tRPC. And we'll keep all of our tRPC server code in here. Inside of tRPC, let's create a new tRPC module where we'll go ahead and actually import our Nest.js tRPC module. So let's go ahead and add the new app module decorator and export class tRPC module. So we'll go ahead and provide module with an array now where we specify our imports. So in the imports array, this is where we'll actually import the tRPC module. And this tRPC module is now coming directly from the Nest.js tRPC library we just imported. And so this is going to take care of actually bootstrapping our tRPC server without us having to do much of anything. We simply need to call for root on it. And that's going to initialize the module and bring in the providers that we need access to. We can also provide it with an options object. And in here we have an important property. That's going to be the auto schema file. So we can see here if we hover over the auto schema file, it's going to be the path to the tRPC app router and helper types output. So what Nest.js tRPC allows us to do is to write our Nest.js code, and it's automatically going to translate that Nest.js code into raw tRPC server app router code. So the app router is the key to tRPC where we can actually get access to the operations and data on those operations like the queries, mutations, and subscriptions. So that's all going to live inside of the app router. And what this auto schema file does is it will automatically generate this schema file anytime we make modifications to our Nest.js code. So we'll see this in more detail by specifying the actual path so that Nest.js tRPC will automatically generate our tRPC app router. And this app router will be key to not only running our server, but also actually connecting clients later on when we want to send requests to our server from the client side and make sure that this is a type-safe operation. Both the server and the client are going to need to access this app router to do so. It's a source of truth for all of our applications operations, those queries and mutations. So let's go ahead and specify the path to be at source. So inside of our source directory and inside of tRPC /@generated. So now with the tRPC module imported, we can go back to our app module and make sure we actually import our application's tRPC module so our application knows about it. Now make sure we don't have a leading slash here at source so that we actually go into our application's source code. And so now you can see after importing this tRPC module and saving, we already can see this @generated folder that's been created for us. And this is the NestJS tRPC library creating this folder and the underlying server TS file where we have our raw tRPC server app router. So again, this code here is all automatically generated for us. It's the raw tRPC server code that both our NestJS server will utilize, as well as the client later on when we need to access this app router type. So this is the big benefit of using NestJS tRPC. It's going to actually translate our NestJS code into this tRPC server code. We don't even have to do anything inside of generated. We can leave that as is now, since we're automatically updating the schema file every time we update our app. So now we have our tRPC server implemented. We can also go to our logs and actually see the app router successfully initializing. So the tRPC generator provider from NestJS tRPC is working as expected. And we can see the tRPC server has successfully initialized using the Express driver, since we're using Express as our underlying HTTP server. And we know tRPC is still operating over HTTP. So this is great. We've set up our tRPC server with this one simple import. Now we have our tRPC server running. Let's go ahead and now start creating our first router. So a router in NestJS tRPC is the actual equivalent to a tRPC router, and it's how we expose our actual endpoints in our server. And so this is going to be the same thing as a controller in a NestJS REST application. So a tRPC router will be equivalent to it. Let's go ahead and get started by creating our first tRPC router in our application. Now to do this, I want to create a new folder called products, where we're going to create some new products related code and have a new products router to actually expose operations, some basic CRUD operations on products. So let's go ahead and get started by creating a new products module. So go ahead and create a new add module here and export class products module. And for now, we'll just leave this empty. So now we have a products module. We're going to go ahead and now create that products router so we can expose CRUD operations over our tRPC server. So in products, I'll create a new products.router.ts. And let's go ahead and now develop. Now, just like we decorate our REST-based controllers with an @controller decorator, we're going to utilize a @router decorator from NestJS tRPC to expose this router to our application. And this is how NestJS tRPC will know to translate this NestJS router into a tRPC server router. We can also go ahead and provide the router with an options object where we can give it a different name if we want with an alias property. So I'll call this products here instead. And now inside of this products router, we can actually define the tRPC procedures that will exist on our given router. So we know these procedures will be a query or a mutation. And so let's go ahead and start off with creating one for all of our CRUD-based functionality. So to start, we'll go ahead and create a new mutation to create a new product. So we'll use the @mutation decorator from NestJS tRPC to mark this mutation. And we'll implement a create product method. And in here, I want to reach out to our product service that we'll go ahead and create to actually offload the business functionality and keep our products router dry and empty, just like a controller. So let's create a product service to do this. In products folder, I'll create a new product service and make sure we mark it with @injectable so that we can inject it into our other providers. And also make sure we go into our products module now, where we want to go ahead and define our product service as a provider. So add the product service, and we're also going to add the products router. So we add all routers as a provider so that they have access to our Nest.js dependency injection system, which is a great benefit to using NestJS tRPC. So now back in our mutation to create the underlying product, I'll return this.product service .create product. And now we need to make sure we, of course, inject the product service into the router. So go ahead and add it to the constructor to utilize our NestJS dependency injection. And we'll also define the create product method now on the product service. And we'll leave it empty for now. So now back in the product router, we have the mutation defined, which is great. But now we want to go ahead and actually define the input and the output to this given procedure. Now in a tRPC router, every procedure is going to be marked with input and output to define the request and response for that given procedure. So in our case, we want to go ahead and define the actual schema for a given product so we can reuse that schema as the procedure input and output. So let's go ahead and do that by defining this new schema inside of our products folder. We'll create the product schema file. And this is where we're going to utilize our Zod library to define the actual definition for our product and have that strict schema validation. So in here, we'll export const product schema, and this will be equal to z from Zod dot object. So we define that this is an object, the actual product schema, and now we'll specify all the properties on a given product that we expect using Zod. Now Zod is a rich schema validation library that supports all different types inside of JavaScript. So let's go ahead and define some properties. We'll have an ID for a given product, and we'll use z.string to mark it as a string. We'll have a name property that's also a string, and a price. And so the price here I'll mark as a number now. We'll also now go ahead and define a details object on a given product. So we have a sub-object in here, and we can just reuse the z.object function to define the object, and this takes in the actual sub-object schema. So within details, I want to have a description for the product and a rating. So we can go ahead and define the properties here. So description will be z.string, and we can also mark this as an optional field, meaning it doesn't have to be provided. And we'll do the same thing for the actual rating property. So this will be a number as well, and we can mark it as optional. So now we have our product schema complete, which is going to define the shape of our product data, which is excellent. Let's go ahead and now utilize this inside of our products router. So now we can actually utilize our product schema, and to do this, we actually provide it directly inside of our mutation decorator as an options object. On here, we can specify the input and output for this given procedure. So for input, we'll simply pass in the product schema directly, since we need the entire product to create a new one. And the output will be a product that we just created, so it will also be a product schema. So now we have defined the actual input and output for this given mutation. Now we want to actually access the given input on the incoming procedure so we can use it in our service. To do this, NestJS tRPC exposes an @input decorator to allow us to actually pull off the entire input object. We can also specify a specific key if we want to access a property on input, like for example, if we only wanted the name of the product. However, we want the whole product that we want to be creating to come back on this variable. So we'll use @input and define this product data parameter of type. Well, we can actually use a type definition directly from our product schema by going back to our product schema and exporting a type in here as well. We'll export type product, and we can use Zod to generate the TypeScript type from the schema we defined, which is another great benefit to this library. We just need to use the z.infer, which then takes in the type parameter, which in our case will be now type of product schema. And so now we have a product type we can use in our application based off of a schema that we've defined. And this is a really clean approach to defining our DTOs. So now back in products router, we can use this product type. Make sure you import it from our product schema. And now we have the product data. Let's pass that into our product service so we can actually persist the underlying product. So now our create product mutation is complete. Go back to our product service where we can implement this functionality. Now in this lecture, we're going to keep things simple and just use an in-memory array to store our products. So let's go ahead and define this products array. We can specify the product type and set it to an empty array. And now in create product, all we're going to do is simply mark the product data parameter of type product, and we just need to push this dot products and push the new product, and also make sure we return the product data back to the caller to satisfy our mutation schema here. So now that we've completed our create product implementation, go back to our app module and make sure we import the products module. So we registered in our application. And now if we go back to our application logs, you actually see here that the products router was registered inside of our router factory, and we mapped the products.createProduct route. So we have really great verbose logging from NestJS tRPC. We can see our new mutation defined correctly. And what I also want to show you is go back into our generated tRPC folder now. If you actually look, you can see our generated server TS file has been regenerated based off of our new router. So as I said before, NestJS tRPC has automatically translated our NestJS tRPC router here into the raw router that tRPC server understands. And this is excellent because it reduces all this boilerplate for us and still allows us to write our NestJS code in a type-safe way. And we're still generating this app router type, which is the source of truth for both our client and server for this given router. So this is great to see our application workflow is working as expected. Let's now go ahead and implement the rest of our CRUD operations. The next one I want to implement will be a get product by ID or find one operation. So we can go ahead and use the @query again. And now we'll go ahead and specify input. Well, this time for our input, I just want to take in the product ID itself that we're looking for. So we can use Zod directly here to specify a new schema type. It'll be a z.object, the request object. And in that request object, we'll just have the underlying ID, which we know is a z.string. Now the actual output itself will still be the actual whole product schema that we pull back from our array. And so now let's go ahead and define the get product by ID method. And we'll use the @input decorator to extract that input. And now we can actually utilize the key parameter to pull off the ID specifically from the underlying object. And that's of type string, as we know. And now that we have the product ID, let's return this product service, get product by ID, and pass in the product ID. We'll go back to product service and make sure we now implement this. So this will be a simple method, get product by ID, that gets passed in the ID of type string, and we go ahead and check to see product by looking through our products array. So we'll use the products.find function to look for a given product in the array, and the predicate here will be if the product ID is equal to the ID passed into the method here. And so now that we have the product from the array, we can actually check to see if it exists. So we can do some validation. So if we didn't find the product, meaning the ID was invalid, then we'll go ahead and throw a special kind of error, the error that we want to throw in our tRPC server. It'll be a new tRPC error that tRPC server actually exposes to us directly. So we can use this error and make sure we're staying compliant with our tRPC server. So the tRPC error takes in a message, and we'll say product not found. And we can also specify a code here. so we can see all of the tRPC server codes that are available to us. In our case, we want to use the not found error code. So these will be equivalent to our REST error codes that we know we have access to, like a 404. This will be the equivalent on our tRPC server. So finally, if we did find the product, we'll simply return that back to the caller, and now we have the product by ID. Okay, so our get product by ID is now complete. Let's go ahead and implement a find all. So we'll go ahead and introduce a new query inside of our router. Find all is not going to take any input actually, so we can leave input empty to mark it as undefined, and the output is going to be an array of products now. So we'll use z.array to specify an array type, and this takes in the actual underlying type of that array, which we know is the product schema, which we already generated with Zod. So now we have the output defined. We'll mark get all products, and we'll go ahead and return this .product service .get all products, and we don't pass in any parameters. So now in the product service, let's go ahead and implement this method, which will be very simple. We're only going to have to do is return the products array we have in memory. Okay, so next up, let's do an update operation. So for update, this will be a mutation yet again. For the update mutation, we want to take an input object. So we'll use z.object. And now inside of this object, we want the ID of the product that we're trying to update, as well as the new product data. So go ahead and mark the ID as a string here. So that'll be the ID property. And then the data property itself, we can actually use the product schema, and then Zod actually exposes a function called partial, which will return a Zod type that will be a subset of properties on the data object, which means we can essentially pass any properties that exist on the product schema that we want to update, which is exactly what I want. And now we'll provide the update product method name. And in here, we want to get access to both of the underlying properties, so the ID and the new data. So we'll use the input decorator twice to extract the ID firstly. So this will be ID of type string. And then we want input again to extract the data from the request object. So this data we know will be of type product, but in fact it will actually be a partial of product, meaning a subset. So this is the equivalent to the Zod runtime method here of partial. This is the TypeScript implementation of only a subset of properties on this given type. So now we have the ID and the data. Let's go ahead and return this .product service .update product and pass in both the ID and the data. Make sure we also specify output for the mutation, which is going to be a product schema that'll be the newly updated product. Lastly, let's now go back into the product service and implement this inside of our service layer. So we'll have an update product method. This will take in both the ID of the product that we want to update and that partial of the given product. So we'll call it data and set it equal to a partial of the product type. So now the first thing we want to do is get the index of the product that we want to update inside of our products array. To do this, we'll use this products and then use the find index array function to find a given index based on the predicate we provide here. So we'll extract the product and we look to see if the product.id equals the ID that was passed into us into the method here. So that means if we actually have the product index, we can use it to update the product in our array now. However, let's first check to see if the product index was actually found. So find index will actually return -1 if the predicate was not satisfied, meaning we didn't actually find a product with this given ID. So we check to see if product index equals -1, then we can rethrow our tRPC error, and let's specify the message. We say that product not found. And we can reuse our code of not found here. So this means that at this point we know the product was found and we have the correct index for it. We can set the product on our products array at this index equal to a new product object, where we'll go ahead and spread all the existing properties on this product. We'll go ahead and access it here by accessing it by the product index. So this will make sure we copy all the existing properties, and then we'll go ahead and spread all of the new properties. And so this will replace any properties that already existed on the product and apply our update operation. So finally, at this point, our product has been updated in the array. Simply return this dot products by product index back to the caller, so we return the newly updated product. So now we have our create, read, update complete. Let's finally go ahead and finish off our router implementation by adding a delete. So delete is going to be another mutation, and it will take in the same input and output actually as our find one by ID. So we can copy this and paste it in here. So we're looking for a product by ID. That's the product we're going to delete. And we'll return the output here. Well, here I don't want to return any product. We'll actually just return a Boolean value. So if the delete was successful, we'll return true. Otherwise, false. And now we'll have delete product, where we'll use add input again to extract the ID of the product that we're trying to delete. So we'll mark the ID as a string, and now return this dot product service delete product and pass that ID in. So let's go ahead and finish off by going to our product service and creating the delete method. I'll go ahead and create the delete product method, and this will get passed in the ID of type string. And we know in here we can now go ahead and, well, we first need to actually get the index of the product that we want to delete. So we'll use the same method we used up above in update product to get the product index. So we'll check to see if the product index actually exists. If the product index was -1, meaning it wasn't found, well, in this procedure's case, I just want to return false. I don't want to throw an error. Otherwise, we can go ahead and remove this product by index by using the splice method, where we pass in the product index and 1 to mark we only want to delete one entry from the array, and return true because we successfully deleted the product. So now at this point, our product router has been fully implemented with CRUD functionality, and hopefully you have an idea of how you can build routers with very little code inside of tRPC Nest.js. It's a very clean, elegant approach that follows strict schema validation on all our DTOs, which I think is a really great approach. We should now be able to see in our logs all of our queries and mutations mapped here. So these look great, just as we'd expect. And so now at this point, our tRPC server is fully up and running, and we've created the products router to implement CRUD. We want a way to actually access these procedures and test out our tRPC server. So we're going to go ahead and do this next by implementing tRPC panel, which generates a UI for us to interact with our server. And the best part is it does this all without us having to do anything, since it can actually generate the UI and all of the operations on it simply by looking at our app router. Let's go ahead and implement this next so we can test out our server. So as I mentioned, we're going to utilize an open source library called tRPC panel, which generates a tRPC UI that we can use to interact with our server based off of our app router directly in our application. Let's go ahead and get started with installing this dependency to actually expose our tRPC server. So we can go ahead and npm install, save, and install tRPC panel. So now we have this new dependency. I'll go ahead and restart my development server. And let's go ahead and get started with integrating it. Integrating our tRPC panel is going to be quite easy. We're actually going to go ahead and expose a NestJS HTTP REST-based controller to actually expose it, and that's how we can access it over HTTP in our browser. So we'll go to tRPC and generate a new file. This will be called tRPC panel.controller. And we'll go ahead and decorate this controller with the controller decorator and export class tRPC panel controller. So this is going to expose our tRPC server through our HTTP UI. We also want to go ahead and implement onModule init, which is going to allow us to actually execute the onModule init function, which we know NestJS calls when this controller gets initialized at application startup. Now we want to do this because when our application is starting up, we want to get access to our underlying NestJS tRPC app router, which we know is accessible through our @generated file. This app router type, which actually generates all of our mutations and queries that our tRPC panel is going to get access to. Now we can actually also get access to this tRPC router through the dependency injection system thanks to NestJS tRPC. So to do this, let's go ahead and first declare the private app router. And this will be of type any router from tRPC server to keep it generic. And then in the constructor, we'll go ahead and use a special injection token that NestJS tRPC exposes. So we'll use the @inject decorator to manually inject this provider. That's going to be called app router host from NestJS tRPC. And this actually gets access to the underlying tRPC app router inside of our NestJS application context. So this will be the app router host of type app router host. And this is going to be key because this is going to be the actual underlying instance of the app router, which we want to be able to provide to tRPC panel so it can execute operations against it through our tRPC server. So what we can now do is simply set the app router in our controller equal to this.appRouterHost and make sure we mark this as private read-only so we have access to it in onModule init. And so the host object has the actual app router instance actually available on it. And so now we have the underlying tRPC router instance. We can go ahead and expose a new route to render our tRPC panel. So now at this point, we can actually start exposing our tRPC panel and hook it up. To do this, we'll use the @all decorator from NestCommon, which is going to map all HTTP methods to this given controller route, and we'll call it /panel. And so now on the panel route, we'll go ahead and create the panel method. And in here, we simply return rendered tRPC panel function from tRPC panel library. So this function takes in two parameters. The first is the underlying app router instance, which the UI will use to actually get access to all the procedures that we are exposing and be able to actually invoke functions against those procedures. So we'll go ahead and pass in the app router instance, and then we have an options object where we specify the actual endpoint of our tRPC server. And this is so that our tRPC UI can make requests against the tRPC server. The UI is essentially just a middleman between our browser and the tRPC server. So tRPC panel will take care of translating the HTTP request on the UI to a given tRPC server request, thanks to providing it the app router and this options object where we specify the URL of the underlying tRPC server. Now in our case, the tRPC server is exposed at /tRPC on our default NestJS port here. So we know in our case that will simply be HTTP localhost 3000, which is our default port, /tRPC is where our tRPC server is listening on, and we're exposing our app router. So finally, make sure we go back to our tRPC module and let's add a new controllers array where we specify the tRPC panel controller. And now at this point, we should see that our server has successfully mapped the panel route, and we should be able to navigate to this in our browser. So now in my browser, I've navigated to localhost 3000/panel, where we can see this really nice UI where we're actually exposing our app router here. And this tRPC panel is automatically generating this Swagger-like documentation against our tRPC panel router that we've automatically generated thanks to NestJS tRPC. And so this is another really great benefit to tRPC is we get this auto-generated documentation for all the procedures in our router for free, which is a really great resource. So we can see all the procedures here that we created automatically have been exposed. So we have our 2 queries. We can click in on any one of the queries and actually see the input here that we have provided. So in this case, that'll be the ID. And we can actually even execute the underlying request. So let's go ahead and try this out. We can see the create product mutation, and thanks to our input and output decorators that we defined, we actually have the input here and the product schema that we know we need to provide. So we'll go ahead and mark some sample values. I'll go ahead and provide a price, and we can leave description and rating as empty since they're not required. And we can even execute the create product procedure now, and we can see we got the response with the created product. If I go ahead and try to query all products now, you can see we get the product back. If we execute product by ID and pass in that 1, 2, 3, we get the product back. Or if I pass in an unknown product, we get the error response here with the status code, code, and message that we expect, as well as the stack trace, which is really quite amazing and really useful for local development. Finally, let's go ahead and update a product. So if we pass in 1, 2, 3, let's say I want to change the product price now to $200. We execute the mutation, get the new product back, and now if I rerun our get product by ID, we can get back the newly updated product. Let's go ahead and finally delete a given product. So now the product is deleted. And if I pull back products, we can see we no longer have any. So this is incredible that we have this tRPC panel that's automatically generating all this documentation and allows us to quickly experiment with our new procedures without having to define any of this. This is all being automatically generated from our app router, and is a great benefit to using tRPC because this allows for rapid prototype development, and you can imagine sharing this with a team member to quickly iterate and develop new APIs with great speed. Finally, I want to show you in the network tab a little bit deeper as to what's going on when we actually generate these requests in tRPC panel. So if we execute the get all products procedure and we click on it, we can actually see it here in the network tools in our browser dev console. So we can see we're actually calling our backend tRPC server here with this HTTP request, and we're targeting products that get all products. So I just want you to see here we're actually still using HTTP protocol to actually translate this request to our tRPC server. We have headers here as well, and a payload actually being sent to the tRPC server, and we can see the JSON response here as well with all of our product data. So now that we've seen all of our CRUD operations exposed through our tRPC server thanks to tRPC panel, let's go ahead and jump into a few more remaining topics in tRPC NestJS, which is going to be applying middleware to our tRPC routers, as well as using context to be able to provide context to our routers and services. Let's go ahead and do this next. So next up, I want to jump into middleware in NestJS tRPC. So middleware inside of a normal NestJS application, or really any Express application, is simply a bit of code, a function that we can execute before every request in our system. And this is usually a great place to implement cross-cutting concerns like validation, logging, or even authentication. So let's go ahead and see how we can implement middleware in a NestJS tRPC server, which it also abstracts for us in a very easy and lightweight way. So let's get started and implemented some logging middleware, which is going to actually make sure we log out each and every request and response that reaches our tRPC server, and we'll be implementing this in one place so we don't have to duplicate it. And because it's middleware, it'll execute for each and every route inside of our router we apply it to. So inside of our application, let's go back into tRPC, and I'll create a new folder now called middleware, where we'll go ahead and create our new logger.middleware. Now we'll go ahead and mark this as injectable because just like any NestJS provider, this middleware, we can actually inject dependencies into if we need them. We'll go ahead and export class logger middleware. And we actually also have an interface that we can implement from tRPC middleware. So this is directly from NestJS tRPC. And now we'll go ahead and now implement the use method from this interface. So you can see here that use gets passed in some middleware options, which we'll look into shortly. And the actual response here can be asynchronous, so we can actually make this async and do asynchronous work in here. So let's go ahead and now implement our logging middleware. The first thing I want to do is get access to a logger so that we can log out to the console. So we'll declare a new private read-only logger and set a new logger. Pass in the class name to get some context as well. So inside of our middleware, let's now go ahead and implement our logging functionality. The first thing I want to do is actually create a new const to track the start time of the middleware because I want to include the duration of the request in the log statement. So we'll go ahead and create a new start constant here and set it equal to date.now. And now at this point, we want to destructure some of the properties we have on this middleware options. So let's go ahead and destructure on the middleware options. We want 3 properties. The first will be next. So just like in Express middleware, this is the actual function we call to invoke the underlying router handler and actually trigger the next portion of the request response lifecycle. So we'll go ahead and call this once we're ready to execute the handler. And then we'll get access to the underlying path, which is the actual router and procedure we're executing. And finally, the type as well. So that'll be a query or mutation. And we can get access to the input, so the data being passed to the procedure. So now we set this equal to options to destructure these properties. And now that we have these properties, let's go ahead and execute the function handler and get access to the underlying return value from it. So we can get access to results and call await next. So since this can be asynchronous, we'll call await here, so in case we're doing some asynchronous work in our handler. And that's why we can also mark the middleware as async as well. So now at this point, we can actually log to our console about this request and response. So now let's go ahead and create a new metadata object with the properties we want logged out. So we'll include the path, type, duration milliseconds will be equal to date.now, so after we executed the function handler, minus the start time, so before we executed the handler, how long did the actual processing of the request take. And so now at this point, we're ready to actually log out this meta object. Let's go ahead and check to see on the result. We have the OK property to check to see if there was an error. So if there was no error, meaning result OK is true, we'll use our logger to log success and the meta object. Else we'll use the logger.error function to log an error message and pass the meta as well. Finally, we need to make sure we return the underlying result, of course, back to the caller so the client gets access to the result value. And now we've successfully implemented this middleware. Let's go ahead and make sure we add it to our tRPC module as a provider so we can get access to dependency injection in case we need it. And now at this point, we should be logging every request and response, but we need to make sure we apply this middleware to a given router. So let's go back to our products router. And to apply it, we simply use this use middlewares function from NestJS tRPC. And we can pass in any number of middleware we want to execute, and it will actually execute these in the order we bind them to. So we'll pass in our logger middleware. Now note you can also apply this on the actual procedure level. If you only want it to apply to one procedure, you can do it at the level here. Or if we do it at the router level, that'll apply to all procedures. So now at this point, let's go back to our tRPC panel. And if we try to execute a products query and now go back to our terminal logs, we can actually see the success log object coming from our logger middleware with the given path of the query, the type, and the duration here. So this is excellent because it gives us some great information about the requests coming into our system, as well as showing us how to apply middleware in our application. So now we know about middleware, let's go ahead and finally learn about how we apply context to our tRPC server. So the context is going to hold data that all of our tRPC procedures will have access to, and it's a place we can put values like request and response objects, as well as authentication information. So let's go ahead and see how we implement context in NestJS tRPC. I'll go into our tRPC folder, and let's go ahead and actually create a new folder called context. And in here, the first thing I want to do is define an interface that will actually describe our context object. So I'll create a context interface.ts. So in this context interface, let's go ahead and export it. We'll call it the app context. And in here, we'll go ahead and define the properties that we want all of our procedures to have access to. And so in our case, I want to add 3 properties. One will be the actual underlying express request object for this given procedure. This will be of type request, and since we're using express HTTP server, we'll import it from express, as well as the response object for this given request. So each request in express will have a request and response object associated with it, and this context will actually store those values on it so we can get access to request specific properties. Additionally, we're going to go ahead and populate our app context with a custom property called user ID. This will be some sample authentication where a common use case is we need to know the user ID in our application layer. We can go ahead and populate this on the app context itself. So now we have the shape of the data. Let's go ahead and actually create a new context class inside of context folder. I'll call it app context. Now let's go ahead and actually rename our interface to iAppContext so we don't have a conflict. And now in app context, we can go ahead and mark this as an injectable class. The context object that we're building here can get access to dependency injection. So if we need to reach out to external services to build it, we can do that in here. And we'll export class app context, which is going to implement tRPC context. So this actually implements a method called create, and NestJS tRPC will call this method on each and every tRPC procedure to actually build the context object. So each request will have its own context. So we're simply going to go ahead and now return our context object, and we can mark the return type here to be of iAppContext, which we know is the interface we just created. So now let's go ahead and return a new object where we can populate our request and response parameters. Now you can see here create's complaining already because we actually get passed in a parameter here, options of type context options from NestJS tRPC. On this context options, we actually have the request and response objects from Express itself. So we can simply set them equal to the request and response from context options. So now at this point, our app context is ready to actually be utilized. To make sure the app context create method is actually called with every route, we need to make sure we go back into our tRPC module and provide a new context parameter to it, where we set app context from context app context that we just created. So now at this point, with every procedure route we actually execute, we'll have access to the request and response object for that given request. And we can remove the user ID from the iApp context as we're not going to be utilizing this. And so now at this point, our app context should be getting applied to every route. Let's go ahead and utilize it inside of our logger middleware. Recall on the actual middleware options, here we have access to the underlying context object for the given request. And we know we just populated this thanks to our create method. So what we can do is we can actually enhance our logger middleware to pull off some properties from the underlying HTTP request. Now let's go ahead and firstly destructure on the given request. So to do this, we'll go ahead and destructure the request and response from our options.context. And let's go ahead and do this after we invoke our function handler. And now we have the request and response objects. We can go ahead and add some additional properties to our logging metadata. I'll go ahead and add the HTTP method that we're using. We can pull that off of request.method. I'll add the status code from the underlying response. So res.status code. We'll add the IP address from where we're actually calling from request.ip. Let's go ahead and mark all the headers here. So we'll output all of our request headers. And now at this point, we should have a lot more information with each and every request. So in addition to assigning the app context, make sure we also add it to our providers array, since it's an injectable class in our Nest.js app. So now at this point, we should be able to go back to tRPC panel and re-execute a getAllProducts request. And now if we go ahead and look at our log, we can see a lot more information about the request, including the status code and HTTP method, which is a GET request now, and the underlying headers for that request. Now these values are all going to be scoped to the particular request we're actually making. And this is thanks to our Nest.js tRPC context object that we just set up. We can actually define custom headers on the tRPC panel. So I'll provide a test value now. And now if we re-execute the query, you can see this new test header has been logged for this given query. So this is great. We now have context. The last thing I want to show you is how to actually get access to the context inside of our router. So back in the products router, let's go ahead and in the create product procedure, let's say we want to get access to the context object in here to get access to a value on it. To do this, we simply use the @context decorator from Nest.js tRPC. So this will pull off the context object for the particular procedure. I'll go ahead and call this context, and we know the type will be of app_context, the interface we define. And so now we have this actual context. Let's go ahead and log it out from within the router here. I'll have a app_context log, and we'll go ahead and add the actual context object to see that we actually have access to it in the router. So now if we re-execute create product, we'll go ahead and create another product here with a different ID, execute the mutations. Now we created the product, but now if we go back to our logs, you can actually see our app context log here with the context object, which contains the request and response. So this is excellent. It means we have access to request specific details on a router level. And we could use this context object to, for example, pull off a user ID after some authentication and actually pass that value directly to the service layer if we need access to it. So now at this point, we've gone through all the essential details for a Nest.js tRPC application. I hope you've learned so much about tRPC and this great Nest.js tRPC library in this lecture. In my opinion, it is the best way to get up and running with a new full stack backend. Today, I want access to the remaining lecture where we actually connect this Next.js UI inside of a turbo repo to our tRPC backend and implement a fully type-safe end-to-end application. Head over to my membership website below, which I'll leave a link to in the description, where you can become a member and get access to the full lecture. So thanks so much for watching this video. I hope you learned so much, and I'll see you in the next one.